Welcome for a mathematics lesson. We're going to do calculus. Determine the turning points of the curve y equals to 5x minus 8x squared plus x to the power of 3. Remember to subscribe to the channel and to also share the link with friends. Now, for us to determine turning points, they are so called stationary points, and we should know that these are the points where the gradient of a curve is 0. The turning points, gradient becomes 0. Therefore, we're going to first of all determine the gradient function, which is the derivative of y with respect to x. So when we derive this function, we're going to have, because 5 is to power x and x to power 1, 5x and x is raised to power 1, we drop 1 to be multiplied by 5, then x is raised to power 0, because it should be raised to, if it was power 1, we less 1. Now we drop 2 to this point to be multiplied by negative 8 to give us a negative 16. Then x will be raised to power 1. X will be raised to power 1. Then the next, we will have to drop 3 to be multiplied with x. Then x now, at that point, becomes power 2. Therefore, the function is going to be 5, because x power 0 is 1. So we get 5 minus 16x plus 3x squared. So that is the equation which gives us the gradient function of this curve. Now, at the turning point, gradient becomes 0. So we're going to equate this function to 0. 5 minus 16x plus 3x squared equals to 0. Now, the equation has become quadratic, and we have to solve it quadratically. Therefore, I'm going to prefer solving this equation by the completing square method. So let me begin by having 3x squared minus 16x, and we take 5 to the other side where it becomes negative. The next thing is to divide through by 3 to make the coefficient of x squared 1 to remain with x squared minus 16 out of 3 x equals to negative 5 out of 3. The other thing is to add a constant on both sides, whereby I'm going to have x squared minus 16 out of 3 x. Then we add a constant, which is given by b divided by 2 squared. So when we take 16 out of 3 and we square, then we divide by 2 and we square. Using my calculator, when I square this value, I'm going to have 7 and 1 out of 9. 7 and 1 out of 9. So this is going to be negative 5 out of 3 plus again 7 and 1 out of 9. So it should be added to both sides. Therefore, I'm going to combine this side. When I subtract 5 out of 3 to this figure, I'm going to have 5 and 4 out of 9. So the right hand side is going to have 5 and 4 out of 9. Then this side is going to have x squared minus 16 out of 3x plus 7 and 1 over 9 should become, this is 63 plus 1, 64 out of 9. Therefore, I'll first factorize the left hand side, whereby I should have x, then minus, because it is the adjacent sign, then the square root of this part, which is 8 out of 3 squared, equals to 5 and 4 out of 9. This is 45, which makes this one 49 out of 9. Therefore, I'm now going to obtain square root of both sides. The square root of this left hand side will become x minus 8 out of 3, and the square root of this side will be plus or minus 7 out of 3 when we obtain square root. Now to remain with x, we need to add 8 out of 3 to the other side because it will change the sign. So we'll start with 7 out of 3 plus 8 over 3, or x to be negative 7 out of 3, we add 8 out of 3. So the two values of x are going to be x equals to be, we start with 7 out of 3, then we add 8 out of 3. This is going to give us exactly 5, or x equals to negative 7 over 3, negative 7 out of 3, we add 8 out of 3. This gives us exactly a third. So these are the values of x, which means because we are determining turning points, then we are supposed to substitute the values of x at the turning point. So at the turning point, these are the values of x, which means now we should substitute them in the original equation to get the values of y at the turning points. So when I substitute x being 5 as the first value, I'm going to have y equals to 5 into 5 minus 8 into 5 squared plus 5 power 3. This is going to give me 5 into 5 minus 8 into 5 plus 5 power 3. This gives me exactly 110. Then I'm also going to get the other value of y when x is a third, minus 8 into a third squared plus 5, x power 3 is a third, a third power 3. So the value of x now is going to be 5 into a third. Then I subtract 8 into a third squared. Then I add a third raised to power 3. This gives me 22 out of 27. 22 out of 27. And this means that now the coefficients of the turning point are going to be 5 and 110. And another turning point is going to be a third and 22 out of 27. So these are the coordinates of the turning points for the given curve. Thank you for following. Subscribe and share.